This lesson is titled Ratios and Proportions. So let's actually define those two words before we jump into actually applying them. Well, what is a ratio? Well, it is a comparison of two quantities using division. So division is the key word there. So a comparison of two quantities using division. What's a proportion? It's an equation stating two ratios being equal. Again, the ratio uses division. Proportion, it takes two ratios that are equal and sets up an equation there. Now, a ratio can be expressed in different ways. But again, you should always reduce if necessary. If you can. So it says they should be expressed in simplest form. So the three main ways you're going to see it is written like this, from A to B, A, and it gives you like that whole colon there, and then as like a fraction. Now, however it gives it to you, we're going to answer in that same format here. So here it says simplify each ratio. You have 24 over 6. So you can actually reduce that. You can divide both of those by 6, which gives you 4. Now, you don't want to leave it over 1 when you're writing it in fraction form. So your ratio here would be 4. Now, in this case, you can divide both of these by 5, and if you do that, you get 3 over 5. Now, when it's in this format, you want to keep it in that format. So here, still the question is, how can you divide, what can you divide 9 and 12 both by? In this case, it would be 3. So 9 divided by 3 is 3, 12 divided by 3 is 4. Now, unlike the fraction where I said you don't leave the denominator equal to 1, when it's written in this format, like here, 6 to 2, you do want that 1 to be there. So this would be 3 to 1. And we see that format a lot when it comes to odds of something, or again, if you're saying like guys to girls, or whatever that ratio may be, this is usually how you see it, 3 to 1. So here, a baseball player's batting average is the ratio of the number of base hits to the number of at-bats, not including walks and sacrifices. If you know anything about baseball, these don't go as an official at-bat, but that's secondary here. Houston Astros' Jose Altuve had the highest batting average in Major League Baseball in 2017. He had 590 official at-bats, and he got 204 hits. So find his batting average. So again, it's hits over total at-bats. So that's the ratio. Now the way they do batting average is they will divide this, and they will round it to 3 decimal places. So you get 204 divided by 590 gives you 346 when you round it to 3 decimal places, which, if you know anything about baseball, that is really good. If you can hit 300 or .300, then that's a very successful year. So 346 is outstanding. That's why he won MVP this year. Anyways, that's how we set up a ratio. In this case, it was total hit, or the amount of hits over official at-bats. Now, here it says extended ratios can be used to compare 3 or more quantities. So, and it's almost always given in this format with the colons here. Now, when it's given in that ratio, I've said here, multiply all the ratios by the same value. So in this case, you would want to put an x behind all these terms. So it says, for example, a ratio of 2 to 5 to 7 will become 2x, 5x, and 7x when you have to plug it into an equation. So here, the ratio of the measures of angles in a triangle is 3 to 4 to 5. Again, we're going to say 3x, 4x, and 5x. Now, we are dealing with a triangle here, so what do we know about the angles of a triangle? Well, they add up to 180 degrees. And again, you're going to need a variable in there somewhere to solve this equation. So you put an x behind all three of those numbers. So that gives you 12x equals 180. So if you do 180 divided by 12, you get 15. But that's not what it's asking. It says find the measures of the angles. Now we had to do that to find x, but now we need to go back and find the measures. So we have 3x, 4x, and 5x. So 3 times 15 would be 45. 4 times 15 gives us 60. And 5 times 15 gives us 75. And the best way to check your work is just add them up. If you got 180, you know you did it right. And if you don't get 180, you know you need to check your work. But the idea here is put an x behind all three of these numbers when you plug it into the equation. So let's do one more of those. In a triangle, the ratio of the measures of the sides is 2 to 2 to 3, and the perimeter is 392 inches. Find the length of the longest side, so that's where our final answer needs to look like, longest side. Well, again, we're going to put x's behind these. 2x, 2x, 3x. But it says the perimeter is 392. Well, how do you find perimeter? Well, you just add up all the sides. It's a triangle. There's 3 of them. You get 392. So now we combine like terms. 2 plus 2 plus 3 is 7x equals 392. So when you divide that, you get 56. So x is 56. But again, we don't want to stop there. It says find the longest side. Well, the longest side has to do with that 3, because that's the longest number in the ratio. So you do 56 times 3, which gives you 168 inches. And again, if you really want to make sure that you're correct, just multiply 56 by 2 into both of these, and then add all three numbers up, and you should get 392. Okay. Now let's talk about proportions. Proportions can be set up in many different ways. Now when it's set up like this, a over b is equal to c over d, the first numerator and the second denominator are called the extremes. Basically the first part of it and the last part of it. And the b, oh look at this, it's a little off. There we go. And the b and the c, so the first denominator and the second numerator, those are called the means. What you do is you multiply them. You multiply the extremes, you multiply the means. And that will help you solve for a variable if there is a variable there. And also to check to see if their proportion is accurate. So the example here, it says if 4 over 10 is x over 15, again you would multiply diagonally. 4 times 15 is equal to 6 times 10. And you get 60 is equal to 60. So that's why we know that that proportion is true. So here it says solve each proportion. Again, we're going to multiply. So you have 6 times 31.5, which gives you 189, is equal to 21x. Again, you go diagonally. And lastly, we're just going to divide. Cross multiply and divide. So 189 divided by 21 gives us 9. That would be your final answer. Now notice on B though, you have to watch out because of that plus sign. It's easy to make a mistake here. Remember, you're multiplying the entire numerator by the entire denominator. But what you're going to want to do is put that in parentheses. Because of that plus sign, you're going to have to distribute the 5. So don't forget to distribute the 5 to the 3 as well. So that gives you 5x plus 15 is equal to 2 times 4x, which is 8x. And now we would subtract the 5x over, which gives you 15 is equal to 3x. So x must be 5 when you divide both sides by 3. Okay? So again, cross multiply. That is what we're doing here. And just don't forget to put the parentheses here so that you get reminded to distribute that 5. Alright, 2 more. So here we're going to do negative 4 times 2y plus 5 is equal to 7 times 6, which is 42. But again, we distribute, and we're distributing a negative 4, not just 4, but a negative 4. So that gives us negative 8y minus 20 is equal to 42. So we're going to add the 20 here. So you have negative 8y is equal to 62. Divide by negative 8, because remember, you want to get y by itself fully, which is going to give you a decimal, but that's okay. 62 divided by 8, which gives us negative 7.75. Alright, and on this last one here, again, we throw in the parentheses. 7 times z plus 4 is equal to 9 times z minus 1. And we distribute. So you have 7z plus 28 is equal to 9z minus 9. So we'll go ahead and subtract the 7z over, and go ahead and add the 9 over. So that gives us 37 is equal to 2z. Divide by 2. Z is equal to 18.5. Just do not forget about these parentheses so that you distribute. Okay? Alright, let's move on here. So let's actually apply this to a word problem now. We're going to do the ratios here. Ed conducted a survey of 50 students driving to school and found that 28 owned cars. If 755 students drive to school, predict the total number of students who own cars. So I'm going to set this up in words first. So you have total students. That's total. We always put the total on the bottom. You technically don't have to, but I like to always put the bigger number on bottom when I set up a proportion. So here I have 50 students driving to school. 28 of them owned cars. So this is the ones that drive cars. Now what you have to do is make sure it matches the same thing on the other side. Cars over students. So that's how we're going to set up our proportion here. So in the first sentence, we see that there's 50 total that he surveyed. 28 of them drove cars. Well, there's actually 755 that drive to school. Sorry. There are 755 total students who drive to school, but how many of them owned their cars? Again, the top is owning cars, the bottom is just students who drive to school, period. So we have our proportion here. We go cross multiply. So 50 times x is equal to 755 times 28. It gives us 21,140, and then we're going to go ahead and divide by 50. So if you divide that by 50, now you'll notice here, when you type that into your calculator, you get 422.8. But we're talking about people. We're not going to do decimals when we're talking about people, so we're going to go ahead and round that. So your answer really is going to be about 423 students. Okay? There's about 423 students who own their cars that drive to school. Not just are driving to school and getting to school, but 423 own them. That's actually a pretty high number. Anyways, let's do another one. In an experiment, students netted butterflies, recorded the number with tags on their wings, and then released them. So some butterflies are being studied, and they have these little tags on their wings. The students netted 48, and 3 of those had tagged wings. So again, if we did this in words, this is total netted on bottom, and on top is how many had tags. And again, we need to make sure that it matches on the same side. Both on top, both on bottom. Tags both on top, netted both on bottoms. So in the experiment, they netted 48, so that goes on the bottom, and 3 of them had tags. Predict the number of butterflies that would have tagged wings out of 100 netted. So again, 100 netted on the bottom. What we're trying to figure out is how many would have tags. So here we cross multiply. So you get 48x is equal to 3 times 100, which is 300. And then you divide. So 300 divided by 48 gives us 6.25. So about 6 of them, just a little over 6, would have tagged wings based on this prediction. Again, it's not a guarantee. That's why it says predict the number. So you're doing a little sample study to predict on how many you would have if the number were larger. Okay, so set up your proportion. Make sure tags over netted. Make sure it matches numerators and denominators. And just as a little recap, equivalent proportions, there are many ways you can, there's actually 4. For one proportion, you could set it up in 4 different ways. So, like if you were to take this problem up here, notice that we set it up 28 over 50 is equal to x over 75. Now, as long as they match, we could flip both sides here. So if you look at this one, notice this one flips it upside down. See, 50 over 28 is equal to 755. Now, notice what they also did here is they could set it up 28 over x is equal to 50 over 750. So you can actually swap places diagonally too to set up that proportion, and you'll still get the correct answer. Okay, what you want to make sure is there's consistency with how you set up your proportion. So here's cars over students is equal to cars over students. So if we did cars over cars, students over students, whoa, that would work as well. Just make sure there's some consistency there. So in this problem, it was cars that people owned in the study over total, and over here it's predicted those who owned cars is equal to students who were surveyed over total amount of students. As long as there's consistency, again, in this case there's 4 different ways you could have set up this proportion. So just because you might set it up different than someone else doesn't mean you're wrong. Just have consistency with your proportion. Alright, that's ratios and proportions. Alright. Good luck with those. Have fun.